Of course, there are a lot of lines that we know really well. For example, if we're dealing with slope-intercept form lines, things like y equals mx plus b. If we have y is bigger than, or greater than or equal to, for that matter, mx plus b, then we're looking above the line. And if we have y is less than, we're looking below. So we have a little bit more of a clearer picture of what that's supposed to look like. We can very easily determine what sort of half plane we'd be getting in those cases. And similarly, if we have horizontal and vertical lines, if we have things like x equals a, and x is bigger than for our inequality, then we go to the right. Whereas if x is less than, we go to the left. Because bigger than along horizontal is to the right, smaller than is to the left. Similarly, if it's a horizontal line, y equals b, if we're looking for bigger than b, we go above, less than b, we go below, because up is bigger on the rectangular plane. So if you have something like y is bigger than 1, we're going above 1. And if we have something like x is at most 2, we're going to the left of 2, where we include 2 in the latter and do not include 1 in the former, because one's strict and the other isn't. And that's basically all we're going to talk about for this week with this material. Like I said, these things are pretty straightforward, pretty natural, and the last section is pretty short, so I stacked a bit onto here to make sure we had that extra space to talk about it. Anyway, the last few things we're going to cover here are slightly more complicated. We're going to be looking at things that are nonlinear, as well as finally getting into some of those systems as well.